Welcome to Geology, everybody. Let's talk glaciers. And I'm going to do this in two videos. We'll do a broad overview of what glaciers are, when they were here, and then for the next one, we'll get into more like what are the features that we see today that are remnants of our glacial past. So first off, most of the time we talk about this. Now, if you're around upstate New York and you're driving around, there's no way you're not seeing glacial features, whether you know it or not. They're all over the place. We talked about landscapes a little bit and like soil formation and how you do those things, right? But keep in mind that, yes, bedrock and climate kind of determine what maybe the land looks like. But very recently, that is up until only about 10,000 years ago, we had glaciers covering most of New York State. And right there near campus, if you're on campus, we're talking the ice being like a mile thick. So that's what we're getting into. Now we're talking specifically about this glaciation. This has happened multiple times throughout the history of the planets. But these ones here aren't ones that have left features that are still distinguishable in this top layer of stuff we've got throughout upstate New York. That's going to be talking about this most recent glaciation during the Pleistocene. That again ended only about 10,000 years ago, which yes, that's a long time ago to humans. But geologically, that's very recent, only 10,000 years ago when these things, about 10 to 12,000 years ago when these things melted away. So when they melted away, what did they leave behind and what does New York now look like because of that? And it's one of these things that maybe you don't realize you're looking at glacial features, but they're everywhere. There's drumlins right off campus. And there's Lake Ontario, for Pete's sake. So there you go. So the two types of glaciers we'll talk about are like continental glaciers, which are going to be very large ice sheets that spread like pancakes. And then I've heard them both called valley glaciers or alpine glaciers. Your book says alpine glaciers, which are going to be flowing down mountains. So for the Pleistocene glaciation, we would have had that in like a spreading center where the glacier was thick is basically the hole that is left that Lake Ontario is now occupying. And it's spread out from there. And it's spread and retreated multiple times. And again, everywhere you look, there are the features that we see. What I'd like to find is the diagram that I was just looking at is about it's the zone of accumulation. Where is the glacier getting bigger versus where is the glacier getting smaller? So that's right here. It's easy to see in a valley glacier. So the zone of accumulation, it accumulates. This is going to be where ice is falling from the sky, snow, and then landing and getting packed and packed and packed. Therefore, the glacier is going to get bigger. And as it flows, it eventually gets to a place where the conditions aren't such that it's growing, but that it's melting away, which we can call the zone of ablation. That's where it's not getting bigger, but getting smaller, right? And that's the easy way to say this, getting bigger over here, getting smaller over here. This can happen on continental glaciers too. They can be getting bigger in the middle, and this spreads like a pancake almost. If you pour pancake batter onto a griddle, it's thick in the middle and it like spreads out. That's kind of what we're looking at here. And then where is there that zone where it's no longer getting bigger, but the climate and conditions are such that that's where it melts. And the big thing is going to be what happens to the sediment that it carries along as it goes. When we get down into features in the next video, that's going to be like all we talk about is as it flows and it picks up sediments or it picks up hunks of rock right off the bedrock. What does it do with those? And what does that sediment look like when it lands? I like this little diagram here. I don't know if I would do any specific questions on it, but it's to say that like if snow lands, and we've all been around for some snow, what's the difference between that and turning into a glacier? And it really is related to the pressure overlying snow, more snow on top of that, more snow on top of that, more snow on top of that. It reduces the air, compresses it, and gets you down to forming a glacier, right? Which can then form. Let me find one other diagram without scrolling around with you guys. This one right here, this red line right here is the upper limit of ductile deformation. We're close to the end of the Marcan period anyway, so let's compare this to what happens with plate tectonics. There's similarities, there's differences too, but there's similarities. Up on top where there's less pressure and you're starting to form that ice, it's going to deform brittly, like we talked about with the lithosphere back when we did tectonics. It'll crack if you find videos of people exploring these, you can if you just hang out long enough near one of these, you can hear cracks as it slowly flows. If you get down enough and there's enough overlying pressure, you can get to an area where it ductily deforms, which means that it flows a bit. And I know it feels strange to think about a solid flowing, but given enough pressure, you can do that. I mean, if you can do it with an ice cube if you really squeeze hard enough. You can feel that it's not 100% brittle. Or think of packing a snowball. You get enough pressure on it and it can morph instead of cracking. So consider that with either one of the types of flow of these two, either coming down a hill with an alpine glacier or spreading out as a continental glacier. And then all you got to do in your head is put like, Oswego right here and the rest of New York right here. Yes, I know this is the Antarctica sheet and not the one that was in upstate New York during the Pleistocene, but it's same thing, right? And if we humans showed up and said, this is New York, a couple of thousand years later, that's what will be left of New York is what did the glacier do to all of upstate New York to mash it up and give us all these cool features. And that's what we'll do in the next video. And that should just about do it for us on this one, just to get ourselves a little introduction. I like this little image here where it shows us approximately that difference, that up here, higher in the mountain where it's colder, when it snows, that would be where the glacier is accumulating, and it comes down and breaks maybe over the steeper part right here. That will be where it is reducing in size, that'd be into the zone of ablation. All right, so now again, coming up will be what does the ground underneath here look like as a result of the glacial motion. That's where it's going to be a little bit more information dense. This video is maybe more of an overview. Ooh, I like this idea too. With those alpine glaciers, if you go and this is like a famous and heavily repeated experiment. If you go and jam a bunch of flags into the ground and then leave and come back towards the center, it flows faster. So those move the furthest, and towards the edges it moves the slowest with drag on the sides. Not unlike what we saw when we did rivers. All right, so when we come back, we'll get into what are all these features, where do we find them in New York, and we'll see you then. So long for now.